Okay, today, who'd like to read the I can statement? Regan. Oh, and guess what? That was yesterday's assignment. Good job. Now read today's on page 59. Okay, so there's a word in there, interpret. What does that mean? What does interpret mean? How many of you speak in second language? Few of you, do you? Okay. Have you ever had to interpret for someone? Okay, what were you doing when you were interpreting it? What's that? Okay, so you were taking the language that they understand and you were changing it into English usually, right? Okay, so interpret means we need to look at it and figure it out, okay? So I can solve a division problem and interpret the remainder in the context of the problem. So sometimes we do a division problem and we have a remainder. Well, we might have to look at that remainder and say, what do we do? Okay, so let's say, and I think I've used this example before, you're sitting at Thanksgiving dinner and you have all your family come. And you set out all these nice tables and you put out nice decorations and you have, so everybody sits down and two people are going, wait, where's my seat? And there's not enough room. So do you say to those family members, shucks, I guess you don't get to have Thanksgiving with us. You can go next door and see if they have room at your table. Is that what you're going to do? No. So what do you have to do? You got to get another table, right? Okay. Same thing. We're going on a field trip. And we can have 85 students, but we have 87 students. So do the two students have to just stay back at school and do work while we go to the zoo? No. What do we have to do? Get another bus. Okay. Okay. So that's one of the strategies, and we'll talk about the others. Okay. A land surveyor rolls a wheeled device on the ground to measure distances. Each full turn of the wheel measures 14 inches. The surveyor measures 1,617 inches of land. How many turns of the wheel are needed to measure the distance? Okay, so what are we going to do? What operation are we going to do? Well, what do we need to find out? How many turns? Good. What do we know? Yes. Good. Each full turn is 14 inches. What else do we know? Good. So that's how far we need to go, right? And so now we need to decide. So use division to represent the situation. So what's the division problem going to be? Good. Equals, right? So now it says divide and write the whole number, quotient, and the remainder. So I gave you a piece of paper, so I want you to make sure you're using this piece of paper. And every square gets a digit. Okay? So we're not starting with one-digit divisors. We're starting with two-digit divisors. Okay? So we're dividing by 14. So the first thing we need to decide is, where is our first digit going to go in our quotient? So knock, knock, knock. Boyfriend is 14 feet tall. Dad is 1 foot tall. Can we do it? No. So we go get Mom. Now they're 16 feet tall together. So where is my first digit going to go? Up top of the 6. So how many digits will be in my quotient? At least 3. Good. Okay, now remember division. What are our steps? How do we remember our steps of division? Okay, but how do I remember that? Remember, we just We have a family, right? This is the family the boyfriend came. So who leads the family? Dad, mom. Who's the oldest in the family? Of the kids, sorry. Sister. That's why she's got a boyfriend coming to meet. Then who does she have? Little brother. And they have who? Rover the dog, right? Okay, so dad, we do what? Divide. Mom, we multiply. Sister, we, whoops, subtract. Brother, we bring down. And Rover is either a repeat or remainder. How do I know if it's a remainder? There's nothing to bring down. How do I know if it's a repeat? We bring something down, so then we go right back up to the top on repeat. Okay, so knock, knock, knock. 16 divided by 14, or 14 times what gives me a number close to 16? 1. So I put the 1 above the 6. Okay, I just divided. Now what do I do? Multiply. 1 times 14 is 14. Now what? Subtract. 6 minus 4, 2, 1 minus 1. And I'm just going to leave it blank. Okay, so we subtracted. Now what? Bring down the 1. Okay, is that a repeat or a remainder? Because we brought something down. So we go right back up to divide. But now we're done with looking at this number up here. We now look at this number where we were subtracting and bringing down. Okay, 21 divided by 14, or 14 times what gives me a number close to 21? Okay, now what? 1 times 14 is 14. Now what? Subtract. Can I take 4 from 1? Nope. So I need to regroup. 11 minus 4 is 7. Good. Is there anything to bring down? Yes. Okay. So since we brought something down, Rover becomes our repeat. Go on back up to divide. 77 divided by 14. Okay, so this is where we kind of need, if we don't know our 14 times tables, we need to kind of guess and check, right? Okay, so if I did 7, why wouldn't 7 work? Yeah, and we'd have to have 28, right? So we still would carry 2. So what would maybe be our first guess? Okay, you want to do 5? So 14 times 5, 5 times 4 is 20, carry the 2, 5 times 1, plus 2, 7. Now that's pretty close, right? What would be 6? 14 times 6. Oh, no, I'd have to add 14 more. Oh, what's 70 plus 14? 84. Too big, right? So I can always kind of say, oh, can I do 14 more? See if I estimated too low or guessed too low. Okay, so the 5 goes there. 5 times 14 is 70. Subtract. Okay, is there anything to bring down? So 7 becomes my what? So I circle it so I know that I'm done. Okay, so we have remainder 7. So it says right here, divide and write the whole number quotient and the remainder. So what's our answer? Good. It says the remainder indicates that the number of turns of the wheel is not a whole number. Use the remainder to find the fractional part of the last turn. Okay, so one of our ways that we interpret the remainder is making it a fractional part. Okay, so let's look at this. How many many times will that wheel completely go around? 115 times. Then we get to where we can only go 7 inches more. Is that a complete turn? No. So we go 7 out of how much? 14 inches. So we go 7 inches out of 14. So we're going to make it into a fractional part. Our numerator is 7 because we go 7 inches. I have how many inches? 14 inches. So my numerator, my remainder is my numerator. My divisor is my denominator. Okay? So down here, write the remainder as the numerator. What's my numerator? What's my denominator? So what fraction of the number is represented by the remainder? 7/14. Or, does anyone know what that is? 1/2. Okay, write down a whole number as it of turns and a fractional part. How many turns of the wheel are there? How many turns of the wheel? There you go. 115 and 7/14 of an inch, or 1/2 of an inch. Well, 1/2 of it's not an inch, right? That's not what we're. It's 1/2 of a turn. 115 and 7/14 of a turn is what we go. Okay, let's find another way we interpret the remainder. I'd like to read this one really loud. Thank you. Go ahead. What do you need to find out? Good. What do we know? 72 acres. Each tank can cover 72 acres. Yep, we got to look at our picture over there to get the rest of the information. Okay, represent the situation using the division problem. What would be my division problem then? Good. Okay, what's my dividend? Oh, dividend. 1,140. What's my divisor? 72. Okay, divide to find the whole number quotient. So here I come over to my paper. And yes, you need to all do it on the paper so that you are lining things up correctly. Okay, knock, knock, knock. Boyfriend is 72 feet tall. That is a foot. He's looking down, right? Is he scared? Yep. Okay. Now mom and dad are 11 feet tall on each other's. They still scared? Yes. So they go get sister. Now they have 114 feet tall with each other. Are they scared? No. So my first number goes above the 4. How many digits in my dividend? At least 2. Every number, every digit after has to have a number above it. Okay, so now we're going. Knock, knock, knock. Or no, I already did that. Whoopsie. 114 divided by 6. Now, let me show you a little thing that helps me kind of guess what I'm going to cover up this 4, and I'm going to cover up that 7. Okay? 11 divided by 7, or 7 times what gives me a number close to 11? 1. Okay? What would be 72 times 2? Well, what would be 70 times 2. 140. So I know I'm way over at 2, right? So I know that 1 is probably my answer. Okay, I did right. Now what do I do? Oh, you forgot about mom. Multiply 1 times 72 is 72. Now what? Now we subtract. Can I take 2 from 4? Yes. Can I take yes? 4 minus 2 is? Can I take 7 from 1? No, so I need to regroup. 11 minus 7 is 4, and I bring down the zeros. So is that a remainder or a repeat? Why? We brought something down. Okay, so we go back. Set 420 divided by 72. Okay, so I cover up my last numbers. 42 divided by 7 is 6. Now, here's the problem with that. If I times that by 6, 6 times 2 is what? 12, so I've got to carry a 1. And I could even say 70 times 6 is, what's 70 times 6? 420. And I already know that that's going to be bigger because of that 2. So can I use 6? No. So what do I need to use? 5. So 72 times 5. 5 times 2 is 10. Carry my 1. 5 times 7 is plus 1. How does that work? Yep. Okay, what do we do? Subtract 0 minus 0. Can I take 6 from 2? Nope. So I need to regroup. 12 minus 6 is 6. So is there anything to bring down? No. So what does this become? So what do I do? Circle it. Good. So I have 15 remainder 60. So we're going to come back over to our book. It says the seed is sold only in full tanks. How many tanks must be purchased to cover the entire field? Okay, so over here we have 15 remainder 60. Okay. Okay, so you have to have the whole tank to cover 72 acres, right? So right now, how many tanks do we need? 15. And that's going to cover that area. But we still will have how many acres left? 60 acres left. So does the farmer just say, oh, well, no, because if he doesn't seed on those 60 acres, what happens? Yeah, he's not going to get the crops, right? So that's what does he lose out on? Money. Okay, so what does the farmer have to do to make sure he covers this entire field? Add one more tank. So how many tanks will he need then? 16. So here's a case of where we need to add 1 because the remainder tells us to. We need to add 1 to make sure that we cover it. So how many acres will the seed from the last tank cover? 60, right? Because that's the remainder. 60 acres. Okay, so do you see how we are interpreting the remainder? Sometimes, and I don't know if this, I'm shocked it doesn't have it. So there's 3 things. We make it into a fractional part, and I'll tell you that if you're dealing with measurement, like you're doing with a recipe or you're dealing with inches or anything like that, usually your remainder will be in a fractional part. Okay, then we have to add 1, and we have talked about a lot of different scenarios where we add 1, and then there's one where we just kind of ignore the remainder. Okay, so if we were just going to ignore the remainder, what would be my answer here? 15. We don't worry about what's the remainder. Okay, we don't have to worry about the extras. We just want to know. That's kind of like the question that we had about the flowers and that they could have 15 flowers in a vase. They needed 15 flowers in a vase and they had so many flowers. Well, if we're only going to fill enough to have 15 flowers each, we're going to add an extra one that has 5 extra flowers in the vase. No, we only want complete vases. So that's where we go. That's the situation where we ignore the remainder. Okay? All right. Fist to 5 on how you're feeling. Okay? Okay, let's do one more and then we'll do a check-off. Milo will cut 136-foot long roll of wire into 16 equal lengths for fencing. He finds that 136 divided by 16 is 8, remainder 8. How long will each length of wire measure? Okay, so we've got to interpret that remainder. So we did the problem, and let's see, 136 divided by 16, and he found 8, remainder 8 is the answer. Okay. It says, how long will each length of wire measure? Do I add more wires? So I say 9 feet? No, because that's not going to give you a correct measurement, right? Do I ignore it and say each wire should be 8 feet? Think about it. If I cut them up into 8 feet pieces and I get to this end, what's going to happen? Not going to have enough, right? So what, again, I said, what do we do? And it's usually measurement. How do we write the remainder? Say it louder. Someone, I heard it over here. As a fractional part. Good. So if I'm writing this as a fractional part, what would be my answer? 8. Okay, where's my numerator? Which number is my numerator? The remainder. Which one my denominator? The divisor. So what's my number? 8 and 8/16 of a foot. Now, can I write this different? Does anyone know what 8/16 is? Yep. So 8 1/2 feet of wire. So each piece needs to be 8 1/2 feet. Now, when I cut those 8 1/2 feet, am I going to be exact when I get to the end? Yes, you will. Katrina has 200 books to put onto shelves. Each shelf can hold 38 books. She plans to fill each shelf before starting the next. She finds that 232 divided by 38 is 6, remainder 4. How many books will be on each shelf? Okay, they already did the problem for you. 232 divided by 38, we found is 6, remainder 4. Okay, so now we need to go back and interpret that remainder. She wants to fill the shelves and she has to put how many on each shelf? 38. And that completes her shelf. She doesn't want to start a new shelf until she has 38. Okay, so she puts down 38. How many shelves, how many books will be on each shelf? Okay, so what is this 6? How many shelves? So is that what you're asking us? How many shelves is she going to use? You have to kind of be careful. You kind of want to get you to see if you're thinking. It asks us how many books will be on each shelf. Well, didn't they already give us that answer? Yeah. How many books are going to be on each shelf? 38 books. Okay. So then we can, what is this? How many shelves, right? She has 6 shelves of 38, and then what does she have left over? 4 books left over. So you need to be very careful in this assignment. Make sure you are understanding what they're asking. Did you even need to do the division problem to answer this question? No, you didn't. Well, they did it for you, but if they wouldn't have done that before for you, would you still have even needed to? No, because it already told you that each shelf can hold 38 books. So how many books will be on each shelf? 38 books. And then there are 4 left over. All right. Let's see fist to 5 on this one. Now, how are you feeling? How lovely if they give you the answers, right? You don't have to do the division problem. Your tip off will be number 3.